Hello, my name is Poeschko.
And I'm John Pacey.
And we work on the Wolfram Cloud project. And today we're going to talk about cloud notebooks, what you can do with them, and the progress we've made over the last year. Hello and welcome. My name is Poeschko, and together with John Pacey, we're going to talk about cloud notebooks today. You might have heard about cloud notebooks already. The basic idea is to bring the full power of Mathematica notebooks to the web. So what we want to do is render notebooks in a web browser without having to install any plugin or any other local software, and also make them interactive by running in the cloud. Just to give a little overview how this fits into the whole ecosystem of the Wolfram Cloud, because I think sometimes there's some confusion about that. Cloud notebooks are certainly a very central aspect of the cloud, but they're not the only part of the cloud, and there's multiple aspects of cloud notebooks. So first of all, they're a type of deployment. You can think of cloud notebooks as sort of another form of CDFs, where you take some interactive content and deploy that into the cloud. But there's also other forms of deployments in the cloud, of course. There's form functions that allow you to easily create web forms. There's API functions that give you sort of lower level control over server-side programming. There's also scheduled tasks and many other things that you can do with the Wolfram Cloud. But besides being a form of deployment, cloud notebooks are also a way to deploy other things into the cloud. When you execute something like cloud deploy, you can do that in a cloud notebook, but you can also do that on desktop. In desktop Mathematica, that's just another form to get stuff into the cloud, so to say. Or maybe you don't care about deployments at all, and then cloud notebooks can just be another way to work like you do in Mathematica, where you make your evaluations, your computations in notebooks, in the cloud in this case, and you look at your results and make certain conclusions from that. So cloud notebooks can be sort of the product that you care about. There can be the way to create the product, or maybe you don't care about the product really, and you just want to work like in Mathematica. There's slightly different use cases, but the underlying technology is always the same. It's this idea of rendering interactive notebooks in a web browser. So let's look at this, how this works. And I probably increase the zoom level here a bit. Can you see this? So this is actually already running in a web browser. This is a cloud notebook. It's just in full screen right now, but you see it's just my Chrome browser running, and the notebook is in slideshow mode. That's why it looks this way. But otherwise, this is exactly what you would get in the Wolfram Cloud with the cloud notebook. As you might know from desktop, this is the familiar notebook interface where you can enter stuff, hit Shift Enter. It does your computation in a kernel that's running in the cloud, and that's also where this notebook is stored, of course. But the interface is all in my local web browser. So you can do simple math like that, or more sophisticated things like integrations. And you see we spent some effort getting nice typesetting to work in web browsers. It's quite challenging, and it's not perfect yet, but it's constantly getting better. Besides the static output, you also have interactive content in notebooks, of course. So you can, with the Wolfram language, create a button like here, and then when you click it, it does something. In this case, just print another cell. But these are sort of the building blocks of our arbitrarily sophisticated user interfaces. And one very important aspect of notebooks is, of course, graphics, and that's what John is going to talk about some more.
Okay. Can people still hear me? All right. So as Jan introduced me, I'm John Pacey, and I also work on the cloud notebooks, and particularly I'm responsible for graphics. So again, if you're not familiar with Desktop Mathematica, there's a symbolic graphics language, which is quite nice to describe and do lots of things for in particular plotting. So here, again, it's a kind of a simple example of 2D graphics to show you that this is, rendered in a web browser kind of natively. Okay, it's not an image here. So we can do resizing, and again, later on in the talk, I can get more into kind of specifics, but just to show you that the way we've implemented this at kind of the box level or in the notebook level. So in this case, it's not just graphics that works, but anything that typesets as graphics box. So in this case, a plot and some other things. So here's another kind of quick example of a graph plot, and this one I wanted to show you because if you've seen this in desktop, if you hover over the points, you get tooltips. So again, we've done this in a way that just kind of flows naturally from regular notebooks. So I don't want to get too much into that, but there's graphics. There's also graphics 3D. So this is quite an interesting case because we have WebGL. So this is a way to access your graphics card via the web browser. So we can do cool things like rotation.
What did you call that?
It's WebGL. So it's an OpenGL spec in the web. So again, this is in a web browser. It's getting access to your graphics card. Jason is cringing at the artifacts there,
Yeah,
but
the artifacts.
anyway,
It looks a
sure.
little bit janky.
Mhm.
Everything, the font looks a little bit, is it Zoom something wrong or something? The fonts look a little bit janky.
Could
They're
be.
normally smoother and look like kind of, I don't know, maybe it's the Chrome or something?
It could be. Maybe on
It's
the.
normally,
Yeah, I think.
it's normally smoother than that.
Yeah.
It looks better than that.
So, but anyway, so again, just kind of to show you examples that this is working in the in a web browser. So again, if I could use two fingers, I can show you that you can zoom and pan and lots of things here. So, and again, it's done in such a way to kind of flow through at the kind of box level. So then everything kind of goes through here. Get there. So yeah. So here's our nice little caffeine plot, which is interactive. Okay. So that's kind of graphics. Another kind of core feature of notebooks is manipulate. And you may have seen this before working in cloud notebooks, but in the last year we've done quite a lot of work to improve performance. Again, in this case, it's doing as much as possible in the client side, and then we still do go back to the server for updating graphics. Again, I'll just go through a few more examples to note that, again, this is fully featured in this case. It's a 3D graphic. You can still rotate it inside of here and swap it around. So it's quite interesting. So then let's do one more. And again, we have animation working. So it's kind of a neat example. So again, not quite reaching the performance of desktop, but still quite good. So hopefully, eventually, that'll be your face when you're rendering all your notebooks in the cloud. So that's the goal. So all right, I'm going to pass it back over to Jan. He's going to talk about dynamic.
Okay. So as you might know, dynamic is sort of the underlying low-level feature that powers manipulate. Sorry. Okay. I'll try it. Be lower. So dynamic is the underlying feature that powers manipulates and all sorts of other interactive features in notebooks. And so in its most simplest form, you have dynamic of something, and then later when that something changes, the displayed form of that dynamic updates correspondingly. There's a lot of other features of dynamic, and we made most of them work in the cloud notebooks in the meanwhile. One thing that we just added support for quite recently is, for instance, dynamic of current image. There's sort of two steps to this. One was to make current image work by adding another form of communication where the kernel can ask for the current image from the browser, basically. And then we also had to make this self-updating dynamic work. So if I now execute this, when you do it the first time, your browser will ask you whether you actually want to allow this website to use the camera. But after that, it will just work, and you see it's dynamically updating as it should. Again, it's not as smooth as dynamic of current image on desktop, and the main reason is that there is more overhead and more latency between the web browser and the server and the kernel here. But it's still working quite well, I would say. Delete that, and again, the underlying dynamic feature that's being used here is this self-updating or self-triggering dynamic, where you start with some variable, and then as you display the dynamic, it updates itself, which causes yet another render pass of the dynamic, and so on. Right. Oh, can you read this? So that was one of the new things. Just want to go over a couple of other new features that we added during the last year. One of them is multiple undo and redo in a very primitive form, I have to say, especially when you compare it to desktop Mathematica. But what we did add support for is undoing deletions, additions, and also edits of cells. So if I add a cell here, then add another cell, and then I delete this one, and I now press Command-C, I can undo all of these things, and also redo, of course, Command-Shift-C, things replay again. And I think being able to undo just deletions of cells, that's something that's really very useful. But other things like undoing evaluations or style changes and lots of other interactions with the notebook, that's not implemented yet. That would require a bit more sophisticated implementation, like on desktop, but that's a start at least. So yeah, if I evaluate a cell and then press Command-C, it will undo this edit and this addition of the cell, but not the evaluation itself. Another thing that we've been working on is copy and paste. So now you can copy graphics, for instance. If I evaluate this and then take this cell, I can now copy this. And what you might sometimes see is this little extra dialog that says data ready to copy. Might be a bit unusual, but what's going on is that when you render a graphics initially in a cloud notebook, it doesn't have all the data that it needs to copy to the clipboard right away. It sort of has only a SVG-like representation, but what we want to copy to the clipboard is really the underlying box structure of the graphics. So the first time you take such a graphics and copy to the clipboard, it will fetch that data from the server, and then you just need to press Command-C again or press this little button because of basically sandbox restrictions in the browser that wouldn't let us modify the clipboard without an immediate user interaction. So that's just a little restriction, but once you have that, you can paste it here in another input cell, and this will work just like any other graphics. It's still a work in progress, this whole copy and paste story. So for instance, copy and paste between cloud and desktop is not as good as it should be. It's a bit tricky, and at least the direction from cloud to desktop, I think that will be able to improve pretty soon. The other direction will require even more work, also on the desktop side. But we're definitely making progress. Another little useful feature is a shortcut to enter lists. So you might have experienced this in desktop Mathematica. It simply means that when I press the star key or Shift 8 on my keyboard, it will create a new item cell. When I press enter, it will create a new item cell. So when you're working on documents that often involve lists, this is a very useful thing because you don't have to go through a bunch of menus just to create an item cell. There would also be this feature where when you press tab, it changes the indentation of the list, but that's actually disabled in this slideshow style sheet. Otherwise, this would work as well. Another thing, notebook dialogues. That's actually building on the same principle that current image uses as well. And what this allows you to do is things like input, where it brings up a dialog. In this case, it's a light box in your web browser, as we call it. So it's still the same web page, not a new window, but just a thing floating on top of your notebook in the same browser tab. And here you could enter an expression, and you get it back as the result of that kernel evaluation. That is not possible. No, I have to remind myself, no, it's just completely inactive.
The question was, when you pop up the dialog, can you still go back and click on the background? The answer is no.
But we're considering to support palettes as well, and that might be the answer to that. So that would be something that sort of floats on the side while the main notebook would still be interactive, and so you could interact with both notebooks at the same time. That's right. Yeah, it's a bit different here. Yeah. I mean, if that's important for some use cases, we could consider. But I think usually when you have a dialog, that's what you want. You want that to be in the center until you close it. And of course, you can also create more custom dialogues, not only this input dialog, but basically you open this dialog and you completely control what this notebook that's rendered in here looks like. So you can have custom cells and then a button to close it, like here. I wanted to talk a little bit about what's going on under the hood, because we've made some changes to this over the last year, particularly motivated by performance improvements. I probably won't go into too much detail, but what we did is basically a completely new approach to how notebook elements are implemented, both cells and boxes. And so we created this new general framework to define encapsulated components, such as cells and boxes, that can that define how they behave by their render method. So if any of you know the web framework React, it's a JavaScript library. This was actually inspired by React, and for some things we still use React. But it allows for more custom control of how we render things. For instance, in cloud notebooks, we need to be able to completely control the positioning and the layout of all the elements on the page. That's something that you usually don't get in plain HTML and CSS. For instance, to have custom line breaking in notebooks. As I said, I won't go into too much detail. The nice thing that this allowed us to do is to write code in a more functional and less imperative way, which is pretty much like the Wolfram language itself, where that's also an encouraged pattern. For you, this should mean that the cloud notebooks become faster, especially the render time of manipulates was improved a lot when you drag a slider or something, and also more stable. So yeah, that's that. I said performance improvements. the one thing that we made improvements for was updating of manipulates, for instance. But then there is still this other question of what happens when you initially load a notebook, because it takes a while, for all the JavaScript code that's necessary to render the notebook to download, and then it needs to execute in the browser, and that can take a couple of seconds. But of course, we wanted to have at least the initial impression of a notebook to come up much faster. So what we do now is we create this HTML cache for every notebook that's in the cloud. And it's basically just plain HTML with some CSS that doesn't need any JavaScript. And when you load a notebook, that's what you see immediately. So it can load quite fast, and then in the background, all the JavaScript is downloaded, and when that's all ready, then the notebook becomes interactive. But at least you see something right away. As I said, this is basically generated for all notebooks in the cloud. Something to keep in mind is that it's usually only generated when you close a notebook. So when you edit a notebook in your web browser, it will only update the cache when you then also close it. And it also happens when you upload a notebook from, let's say, Desktop Mathematica. I should also note that it's not working completely perfect yet, so there are cases where a notebook should have a cache, but it doesn't. But we're working on improving that constantly, of course. And speaking of loading things, John is going to talk a little bit about graphics loading too.
So graphics is slightly different in that we're not doing everything entirely on the client side. So if you notice during the WebGL rendering, that was quite fast and smooth because that's all happening in client side. There are certain things for graphics that we can't push all the way on the client side. We need to get more data from the server, and specifically the server side front end. So what happens is when you're going to evaluate a graphic that would require going back to the server, that wasn't super obvious what was going on. So we recently introduced this kind of placeholder behavior to kind of show you something is going on, and also to have an approximate size of what that graphic is going to be. So I'll shut up and show you, because then it'll make a lot more sense. So in this case, we're artificially entering a pause, which it'll wait for. So here, that's our loading indicator, approximately the size of what the graphic will be. We go back to the server. Once we get it, then you replace it. You're typically not going to see that for graphics, for 2D graphics, because we try to pre-generate that when you hit Shift Enter. Currently, for 3D graphics, we always request that. So it's quite fast. For this example, if you can see that, we're always going to the server to request data to render it. For 3D, once we're there, it's fine. So everything here is happening on the client side. But the initial and ending ones aren't. So here's a different example for that. So that's one small improvement to kind of show you what's going on, as opposed to for a notebook, a lot of times the feedback was, we don't know what's going on. I'm just waiting for something. Okay. Jan, I'll switch back to Jan to talk about deploying notebooks.
So I just want to mention this briefly because I don't think it's been covered elsewhere in other talks. The basic idea is, of course, that when you have your dynamic interface, typically a manipulate, there's an easy way to get that into the cloud, and the function to use is, of course, cloud deploy. When you execute this, you get back a cloud object that contains a URL, and now this manipulate is just running in this cloud notebook. Small here, and this is now interactive and using a cloud kernel to update the manipulator as a drag the slider, of course. Something to keep in mind is permissions. So when I deploy something to the cloud, by default it's only going to be private, which means that I only I, being logged in into my cloud account on the Wolfram Cloud, can see this. If you want other people to see this and also be able to interact with it, then you need to change the permissions. You can either do that at deploy time as an option to cloud deploy, or you can also do it after the fact by calling set permissions to add permissions for certain user groups. There's also set options where you can completely override the permissions option to a cloud object. In this case, I set it so that everyone, even unauthenticated users, can read and also interact with this notebook. Also keep in mind that these interactions, they use a cloud kernel, which will use your cloud credits as people interact with the notebook. There's also there's many functions to interact with the cloud from the Wolfram language. Sort of a very low-level function would be to just copy a file from your desktop computer to the cloud, and the function for that is copy file, called with in this case a plain string to denote a file on your local file system. And here the second argument is a cloud object, which means copy from the local system to the cloud system. It would also work the other way around, for instance. You give a cloud object first and copy down to your local file system. Once you have something in the cloud, one typical thing to do would be to embed your deployed cloud notebook on a website, for instance. You can use an iframe to embed it in a website or on a WordPress blog or whatever. One thing that we thought would be nice is if you would still have some control over the notebook from the outer web page. So we developed this API that you can use to sort of reach into a notebook embedded on a web page from JavaScript running on the outer page. And we've been using this API for quite a while now, at least internally. For instance, the Wolfram Cloud mobile app is making use of this API. But I think at this point it's quite stable, and so we want to share this with you and to at least get some feedback how we should extend this and how this is useful. So to give you a little demo, also for one thing we added just recently is it allows you to control the variable in a dynamic module. You might notice or not, the dynamic module is sort of the underlying construct used by manipulate. So whenever you have a manipulate, it uses a dynamic module to wrap to create a local variable for things like the X here. So I now have this HTML page, and I'm in full control over this HTML. I can look at the source, and I just wrote all of this. But then I have this iframe here to embed the cloud notebook as well. And what I can do now is I can also create a button that executes some JavaScript. And in this case, it will ask me for a value, and now I can enter something, and it will talk to the cloud notebook, which will then update its state accordingly. Also implemented another function that just continuously updates the variable in steps, and so you get this animation, which you could also get from within the Wolfram language, and usually that's the preferred way to do it. But if for some reason you have an outer website that's already defined, like a big web platform or whatever, and you just want a little notebook embedded in there, then this can be very useful, I think. Sure. So, not sure how much I should go into detail here, but I have this little helper module that just wraps some of the technicalities of interaction between the two browser windows, and then it's just a matter of calling an API method on that. Yep. So what happens here is, I'm not sure if that's a question, but what happens here is you pass in the ID of a cell, so you need to have a handle of a cell, and there's another function to enumerate all the cells in a notebook. And then you pass in the ID of that, and then it just takes the topmost dynamic module in that cell. Right, it's a dynamic module box. Yep, absolutely. We could make this more fine-grained maybe in the future so that you can reach into arbitrary boxes, but for now it's just the top level manipulated in this case. That is not possible yet, but that's exactly the sort of feedback I'm looking for. That could be a useful thing. Right now, it's sort of assuming that you know what you deployed, and so you know the variable name. And if you give a one that's not existing, then it will just give you back an error. But if you wanna look at the details, I deployed this documentation for this API. It lists out all the methods that you can call, what the parameters are, and so on. And I would love to get feedback on that. As I said, it's not completely, it's not a completely official API yet, so things might change, but I'm very confident that they won't change too much. Mm-hmm. Yes, we do have events, maybe not for the things you just mentioned. So there's an API method to add an event listener or to remove one, and then the events that we have is for selection change, evaluation start, evaluation stop, and some other things. Yeah. Oh, you mean the thing we showed in the beginning for the integrate? That is not directly possible, unfortunately. What you can do, you can take a screenshot, obviously. What we do support is, I think, so if you just look at something like this here. This is just the browser rendering stuff. So when you select it, you sort of depend on the browser to what it will copy to the clipboard, and that's not always a very nice thing. But what you can do is here in the cell menu, we have copy as, and maybe this doesn't like me in the full screen mode, or it's just the zoom level. I don't know. It's weird. What this should show you is an option to copy it as an image, at least. So, yes, same idea. Or that's a very good point. So, if the content is already in the cloud, then maybe the easiest thing to do is just send a link to that cloud notebook. And actually, interesting point. What we're also working on right now is having links to individual cells. So let's say if you have a very long notebook and you care about a particular cell, then we'll have a way to have an anchor for that particular cell. All right. Well, we're almost at the end anyway. Just wanted to mention this document as well, because that's one of the things that I think we've always been missing is a better documentation of what are the things that we expect to work in the cloud, what are the current limitations, what do we expect to change. And so this document here that the link is in the slideshow notebook. This is the start of getting better at this. So just wrote up some of the things that common pitfalls, maybe some of the technical limitations, and also some background information about how we do certain things, which might be interesting if you reach certain limitations. So that's that. Of course, we're constantly working on improving this interface. We're certainly aiming for feature parity with the desktop product, but that's a long history to catch up with. So, but some of the things that we're trying to implement as well is the spell checker, for instance. We're constantly making improvements to the typesetting, such as the spanning characters and things like that. They're not perfect yet, but getting better. And in general, we just try to have complete support for all the boxes, which are the low-level typesetting constructs, and their options. We're basically at a point where the options are all supported. The boxes are all supported, but not all of their options. So that's sort of near-term goals. Further out in the future is still the idea to be able to edit all those typesetting constructs. You know, when you have superscripts or grids. In desktop Mathematica, there's a nice editor for that. We don't have that yet in the cloud, but the goal is certainly to have that at some point. And then also live collaboration on notebooks. That's also another big goal of us, to sort of have 2 or more users editing a notebook at the same time and seeing their edits in real time. Thank you very much.